Hi, my name is Tom Murphy. I'm a physicist at the University of California, San Diego, and I want to talk to you about what physics says in terms of our trajectory and making the case for systemic transformation that we'll need to carry out. So we're going to start with the idea of growth and exponential growth so that when any system grows in proportion to its current scale, that is a prescription for exponential growth. The result, if plotted, looks like a hockey stick curve so that it's boring and near zero for a very long time, and then it shoots up to this impressive, almost vertical expansion and this explosive change. So physical systems can exhibit exponential growth for some short period of time, but indefinite exponential growth is not possible in a finite system that only has limited resources and room to grow. But meanwhile, our institutions and the expectations around those that form during a growth period are generally going to be short sighted and very much confined to kind of a phase and will ultimately be unsustainable in the long term. We're going to use physics to show how growth is not really viable for the long term and even in economic terms. So physical growth, which I mean things like population, resource usage, or really any physically measurable quantity, can't carry on indefinitely, and we're going to use energy to illustrate this. Economic growth is likewise constrained as a result, and that might surprise some economists who think that decoupling can between physical goods and economic activity can really allow unfettered expansion of the economic enterprise. But I'm going to sketch out where that breaks down. So looking at energy over a few centuries, we have blue dots representing US energy and a red line that's a fit. The fit is applied in the right-hand panel, which is a logarithmic axis, and that puts an exponential curve as a straight line. So any straight line on this right-hand plot is exponential. The data are impressively good as a kind of linear feature that goes for hundreds of years at something like a 3% rate. If we take the current power output of industrial society of 18 terawatts, and that's the rate at which we use energy, then reduce our 3% per year conservatively to 2.3% per year. And we do that partly because that results in a very convenient scaling of a factor of 10 every century. Then in something like 400 years, we would reach all of the solar energy absorbed by the Earth. And if we were not content with that, we could conceivably harness all of the light output from the sun all around the sky in some, absurd engineering fantasy. And even then, we only get 1400 years. Some might realize that the sun is not the only star in the galaxy. There are 100 billion of them. But that, even at a factor of 10 per century, just buys you 1100 years. That's 10 to the 11 stars. And so in 2500 years, we're spent on the entire Milky Way galaxy. And that's clearly impossible because it takes 100,000 years for even light to traverse the galaxy. So we can't imagine within 2,500 years harnessing all the power from all those stars. So it gets absurd. And even if we allowed the entire visible universe for some, physically impossible extrapolation, it's just 3,600 years, 100 billion galaxies. Again, you just get 1,100 years. So if we confine our activities to the Earth surface, because space colonization is best left to the entertainment industry, then extrapolate our 18 terawatts at this 2.3% per year, we find that the surface of the Earth actually reaches the boiling temperature of water in about 400 years and would exceed the solar surface temperature of about 6,000 degrees in less than 1,000 years. I'm not talking about climate change here or carbon dioxide. This is just the waste heat as governed by the radiation of infrared energy from the Stefan Boltzmann law of physics. It's independent of technology, even if we have some unnamed, undiscovered technology that comes along, as long as it obeys thermodynamics, then we're stuck with this limitation. So the growth phase in energy is limited to a few centuries. Now, where does the economic part come in? If physical growth stalls, this is the blue line on a logarithmic plot, if it stalls, and in fact, that's sort of best case scenario, it might actually decline, then if we were to demand that economic growth continue in this red straight line is exponential in this plot, then there's a gap that grows between the scale of the economy and the scale of physical resources. And that just gets bigger and bigger, so that the magenta curve indicates what fraction of your economy, your expenditures, are in these non physical forms. And so it saturates at 100% and basically says that all of your income, all of your purchase power is going toward non physical goods and services, trading art, psychotherapy, and even those aren't free of energy and free of physical resources. But it's really absurd to imagine that something that's finite and physically um, absolutely essential for life and it's limited would suddenly become free because it's 0.01% of the economy or something. So really, the red dash curve is more realistic that once physical growth saturates, so will economic growth. It might be a little bit lagged for, increased decoupling to some extent. It's just not going to go forever. In an energy context, we can look at the exponential energy increase that we've witnessed as just the left-hand side of a fossil fuel pulse. So we know that the fossil fuels are finite and limited, and we know that the story so far is almost entirely one of fossil fuels. That's going to peak sometime likely this century, and the future beyond that is incredibly uncertain. We have not ever demonstrated the ability to run a technological society on anything but fossil fuels. Now we have some other technologies, that's true, but just bear in mind that so far the story is one of fossil fuels, and that's a limited time prospect, and it's created something that I think of as a fireworks show. We don't know what life looks like beyond the fireworks show. That's worth bearing in mind. So if we think about long-term success, think about this question: is human civilization in its infancy or nearer its end than its beginning? And if we're to be in our infancy, since civilization is about 10,000 years old, we have to be thinking on 10,000 year and longer timescales. Then we can ask ourselves the question: what present activities would still be possible in 10,000 years? So obviously not fossil fuels, deforestation, soil degradation, water depletion, even mining of finite resources, any environmental degradation. It just can't go on. So anything that is not long-term sustainable, which by the way is most everything that we do today, is actually going backwards for us. It's promoting ultimate failure. If it's not contributing to the modes that are long-term successful, and it's very easy to define what that has to be, um, we're actually hurting ourselves more than we're helping. So ultimate success, if we are to carry on as a technological society for a very long time, it critically depends on very long-term planning and maybe even something called wisdom. So we're clever enough to basically destroy our life support system. That's what we're doing right now in ecosystem damage. But are we wise enough not to do that? We shouldn't do things just because we can. We should really think about the long-term consequences and well beyond our own lifetimes and generations of even people that we know are alive today. So meanwhile, the economic constructs deliberately, explicitly have a discount value that puts zero value on the far future. And if that's not a prescription for a worthless future, I don't know what is. We've baked it right into the books that we are promoting a now economy at the great expense of future prosperity and happiness. So it's elegant, but it's going to maximize ultimate failure. It's a system that we really need to remove. It's one of many systems that we need to think about modifying. So just to be clear, climate change is important. It's just one symptom of a much larger predicament of growth and our basic foundations. It's the visible tip of the iceberg, but it's not what's driving all of this activity and all of these global problems. So ultimately, we need to learn to operate within planetary limits. And to succeed at that, the current paradigm has to end, and physics says that the current paradigm of growth has to end anyway. So meanwhile, this fireworks show that we're living in has made us terrible judges of what normal looks like. We can't draw on the experience of our lifetimes and those of uh, our recent ancestors to tell us what paths are viable. It's just it's been cooked the wrong way. So we need transformation across the board on our economic systems, political systems, our own values, our expectations for the future, and even our identity of what it means to be human. Maybe we're not to look at ourselves as the dominant species, but as a subordinate partner uh, within nature, and one smart enough to cause great harm. And hopefully, we can refrain from doing that. So, if we look at what institutions might help us, corporations are short term and profit motivated. Democratic governments also short term, focus on elections and electoral results. It makes politicians into followers, not leaders. Authoritarian regimes have the luxury of thinking longer term, but typically for narrow national gains and not for global global win. And likewise, military operations can think strategy for very long terms, but it's about prevailing in contests over others. It's being victors, not some global cooperation, some uh, sort of more desirable end. So academics might be the only people who can think long term, have the freedom to do that exploration, and might even in some cases bring some wisdom. So we've started this thing called the Planetary Limits Academic Network, or PLAN, that's trying to bring collaborators together around these important topics who can boldly push out into these new directions with new ideas. And we're going to build some tools that allow people to find each other and collaborate in new ways. If you want more perspective on the physics take on this predicament, you can look at this open access or free textbook that is written for general audiences and meant to be pretty readable. It's called Energy and Human Ambitions on a Finite Planet. It's got a fairly broad scope that covers some of the things I talked about here in terms of growth and economic limitations, but also talks about fossil fuels and its consequences like climate change um, and the various pros and cons of alternative energies, and then even human factors like psychology and politics and personal action. So thanks for listening.